All right, welcome back to Activity 8-2, Solving Square Root Equations. So you should have tried each of these, try these. So I'm going to go through them and you can check your answers. So the first one, again, this is page 108. And this is try these A. We have 2 minus square root x plus 1 equals -5. Now earlier I said if you have a square root equal to a negative, you can stop. However, you do need to have the square root isolated. So we're going to follow our steps, which is step 1, we're going to isolate the square root. To do that, I would subtract 2 from each side. I get negative square root x plus 1 equals -7. And then I would divide both sides by -1. And I get square root x plus 1 equals +7. So now at this point, I see I do not have a square root equal to negative. And go ahead and square both sides. So square both sides. And so when I square both sides, I will get that my square and my square root are inverses. So I have x plus 1 equals the square root of 7 squared, I should say, is 49. And then I'll solve for x. So I subtract 1 from each side. I get x equals 48. Now I have to do my check. So my check. Checking this back into the original equation, I have 2 minus the square root of 48 plus 1 is equal to -5. And I am checking, so I'll put a question mark there. And so that gives me 2 minus the square root of 49 is equal to -5. So 2 minus the square root of 49 is 7 is equal to -5. And -5 is equal to -5, check. So you should have gotten x equals 48 is the valid solution. So x equals 48. All right, let's do the next one, the try these B. So this time we have B, the square root of x plus 4 is equal to x minus 8. So the first step is to isolate the radical. But the radical is already isolated, so we can skip that step. The next step is to square both sides. And so when I square both sides, I get, I'll do that in blue, that my square and my square root are inverses, so I have x plus 4 is equal to, now you need to use caution. Again, I'm going to do this off to the side, x minus 8 times x minus 8. That's x squared minus 16x plus 64. You can either use distribution or you can use a generic rectangle, right? X minus 8, x minus 8. And so that's x squared minus 16x plus 64. At this point, what you should notice is that you have a quadratic. So to solve for x, we're solving a quadratic. So we're going to move everything over to one side. So we're going to set that equal to 0. By subtracting the x and the 4 from each side. So I'll subtract an x and a 4 from each side. So I get 0 equals x squared minus 17x plus 60. Now at this point you can choose either to try factoring or go directly to the quadratic formula. I'm going to try factoring. I'm going to see, is there anything that multiplies to 60 but adds to -17? So let me grab my handy dandy calculator. And so 60 divided by 12 is 5, right? 60 divided by 12 is 5. And so I believe my two numbers are -12 times -5. So factor this by grouping, right? So we're going to factor by grouping. So I get 0 equals x squared minus 12x minus 5x plus 60. And then I'll split it and take out the GCF, which is x. That's x minus 12. Bring down my negative. I'll take out the GCF, which is 5. That's x minus 12. And then I'll group my two terms that are left over together. Now, after I factor, I use the zero product property. Oops, my pen is running out of ink. Hang on just a second. Let me switch to a different color. So I'm going to apply the zero product property, which is that I'm going to take each factor and set that equal to 0. So I get x minus 12 equals 0, x equals 12. X minus 5 equals 0, x equals 5. There's my two solutions. And my last step is to check. So I'm going to have to move to another sheet of paper to do my check. So still on page 108, and now we're doing our check. All right, so we're checking our two solutions. Remember, we had two solutions, x equals 12 and x equals 5. And we're checking those in our original problem. Our original problem is the square root of x, which is in this case 12, plus 4 is equal to x minus 8, so 12 minus 8. And we're going to simplify, so that would be, and we're checking, remember, so we're questioning it if it's equal or not. Square root of 16 is equal to 12 minus 8. 4 is equal to 12 minus 8 is 4. Check. So 12 is a valid solution. All right, our second solution we're going to check is 5. So 5 plus 4 under the radical is equal to 5 minus 8. I can see right now that on this side I'm going to get square root of 9 equals, and on this side I'm going to get a negative 3. Remember, the square root cannot equal a negative. And so this is an extraneous solution. And so we have one good solution at x equals 12. All right, let's move along to C. So we're going to try the C. I'm going to rewrite this right away as square root x plus 6 is equal to negative x. At this point, if this were a negative number, I would stop. However, if x is a negative value, this may have a solution, so we're going to proceed. All right, so step 1 is to isolate the variable. Isolate the radical, but the radical is isolated. So at this point, we're going to square both sides. And those are inverses, so I'll get x plus 6 is equal to x squared. So again, that was square both sides. And now we're going to solve. This is again a quadratic, right? So to solve, we're going to have to set this equal to 0 because it is a quadratic. So I'm going to subtract x and 6 from both sides. I get 0 equals x squared minus x minus 6. And now we're going to try to factor. We could try the quadratic formula if we prefer. But I do see that this does factor. There's negative 3 times 2 is negative 6, and negative 3 plus 2 is negative 1. So I'll factor by grouping. That's x squared minus 3x plus 2x minus 6. So I get x squared. I'll split it and take out the GCF, which is x. That gives me x minus 3. This side, the GCF is 2, so that gives me x minus 3. And that gives me x minus 3, x plus 2 equals 0. Now apply that zero product property. And so the zero product property is that we take each factor and set it equal to 0. So I get x equals 3 and x equals negative 2. And now my check. I'm going to check each of these into my original. My original was square root x plus 6 is equal to negative x. So I'm going to substitute in 3, and I'm going to substitute in negative 2 and see if both or either work. So when I substitute in 3 here, I get square root of 3 plus 6 is equal to negative 3, and I'm going to stop right there. When I have a square root equal to a negative, this cannot happen, so this is going to be an extraneous solution. I will check my other solution. Square root of negative 2 plus 6 is equal to negative 2. So this will be square root of 4 is equal to, this becomes positive 2, and 2 is equal to 2. Check, that is true. So our one valid solution is x equals negative 2. So x equals negative 2 is the solution you should have gotten. And I'm going to move on to another sheet of paper to do the next one. So the next one is page 108D. And we're going to, D. We have x plus 4 to the 1/2 plus 1 equals 0. Immediately I'm going to rewrite that as the square root of x plus 4, and then plus 1 equals 0. I'll subtract 1 from each side because I'm isolating the radical. Isolate the radical. I get square root x plus 4 is equal to negative 1. And now I can stop. There's no value that will make this true, so there is no real solution. And that is because we have a square root equal to a negative. That cannot happen, so no solution. All right, I hope you got all of those right. If you did not, you should be asking me in class tomorrow regarding these problems. All right, so the next question says solve the Hall speed equation that you wrote in item 18 of the previous notes. So I'm going to go back to that Hall speed question. That was this equation. So to solve, remember, to solve means that you are finding where this crosses the x-axis. And so the x-axis, right, that would mean y equals 0 on the x-axis. So to solve that Hall speed equation, I have h of x is equal to 1.34 square root x. Again, to solve means we're going to let y equal 0 because we're looking for where this crosses the x-axis. So 0 equals 1.34 square root x. I would divide both sides by 1.34 to isolate my variable, or sorry, my radical. Oops. And that would give me 0 is equal to the square root of x. I would square both sides, and so I get x equals 0. And so the solution to this equation is at x equals 0, which if we look back at our graph, the solution was at x equals 0. That was the only point at which this this square root function touched the x-axis. All right, so for the next one, it says construct viable arguments. Maggie claims that her sailboat, My Hero, has a hull speed of 7 knots. The length of her boat at the waterline is 24 feet. Is Maggie's claim reasonable? Why or why not? So we could verify this algebraically. So we're on number 2, constructing viable arguments on page 108. And so she says that her length, by the way, her length is x, right? She claims the length of her boat at the waterline is 24, and that the hull speed, h of x, is 7 knots. I'm sorry, 24 feet, right? So we're going to verify this in our equation. So we could do this in 2 ways. We can either use our equation h of x equals 1.34 square root x and plug in the values on both sides. So 7 knots, 7, should equal 1.34, and then square root of x, x is 24. Let's go ahead and check this on our calculator. So 1.34 times the square root of 24 equals 7 is equal to 6.56. It would appear that these are not equal, right? 7 is not equal to 6.56. That's one way to verify it. Another way to verify it would be graphically. So graphically, I would have to graph this all the way to 24, but I believe that they did that on the last page of our notes, which is on page 106. So please look at page 106. That's where I'm looking. So pull out page 106. I'm looking at 24 feet, and it looks like at 24 feet I am below, in fact, we'd already done this, right? I am below 7 knots. So graphically, that is incorrect as well. Okay, so explain why or why not. No. When I evaluate h of x at x equals 24, I get 6.56 knots, not 7 knots. Right, at this point you should pause the video, and we are going to do the check for understanding. So you're going to try each check for understanding. So I'm going to do that on a separate video. So pause here. I'll see you on the next one.